The ancient volcano on the island of Thera had an ultimate weapon. It was not fire, nor rock, nor ash. It was the sea itself. In approximately 1600 BCE, this volcano did not simply erupt. It engineered a cataclysm where the surrounding Aegean Sea was transformed into the primary agent of destruction. This event would rewrite the very understanding of volcanic power. To understand how, we must look deep beneath the waves. Santorini is not an isolated mountain of fire. It is the violent product of a vast geological engine called the Hellenic Arc Subduction Zone. Here, the massive African plate is slowly forced to dive beneath the smaller Aegean Sea plate. This grinding descent, a process called subduction, generates immense heat and pressure. It melts rock into the magma that fuels Santorini's fury. But not all magma is created equal. The molten rock brewing beneath ancient Thera was exceptionally dangerous. It was a specific type known as dacitic magma, a substance incredibly rich in a mineral called silica. Silica acts as a thickener in magma. It creates an incredibly high viscosity, making the molten rock move less like fluid and more like a thick, sticky paste. This thickness is critical as it prevents volcanic gases from escaping gently. Instead, gases like water vapor and carbon dioxide remain trapped within the dense magma. The pressure builds and builds. The entire magma chamber effectively becomes a geological scale pressure cooker, primed for a catastrophic release. When that pressure finally overwhelmed the rock containing it, the eruption began. Its initial stage was a classic Plinian eruption. A colossal column of superheated ash and pulverized rock was ejected at supersonic speeds. This pillar of destruction rocketed upwards, punching through the atmosphere to an altitude of over 36 kilometers. It reached the stratosphere, blotting out the sun and turning day into an ash-choked twilight across the ancient world. Yet, this was only the prelude. As cubic kilometers of magma were violently removed from the chamber below, a terrifying void was created. The roof of this chamber, the very island of Thera, lost its geological support and began to fail. The enormous mountain, its heart now hollowed out, could no longer support its own weight. Gigantic ring faults, concentric circles of profound weakness, fractured around the empty magma chamber. The rock groaned under immense strain. It was the sound of a world breaking. With a final catastrophic shudder, the entire central cone of the island began its descent. It wasn't a slow slump. It was an abrupt, terrifying failure. The keystone of the Aegean was falling into the abyss it had created, and the sea began to watch and wait. Then, the barrier failed. Trillions of gallons of cold seawater poured over the fractured rim of the caldera. It cascaded down cliffs of red-hot rock, a waterfall plunging directly onto the exposed, superheated magma below. This was the trigger for a new kind of eruption. This was a phreatomagmatic explosion. The name itself explains the physics. Phreato, from the ancient Greek word for a well, signifying water, and magmatic, for the molten heart of the earth. It is the most violent interaction in all of volcanology. Water meeting magma. When the 1,100 degrees Celsius magma touched the cold Aegean Sea, the water did not simply boil. It flashed into steam instantaneously. It detonated. This event transformed the volcano from a terrestrial disaster into something far more powerful. The sea itself had become the weapon. The physics of this phase change are staggering. 1 cubic meter of liquid water, when flash heated, expands to nearly 1,700 cubic meters of steam. It is an almost incomprehensible increase in volume and pressure, a force of explosive expansion. Now, apply that principle to an entire sea flooding a vast, open magma chamber. The resulting series of explosions dwarfed the initial eruption. Each blast released energy equivalent to hundreds of nuclear bombs, tearing the volcano apart and vaporizing billions of tons of rock and water. These were not simple steam explosions. They created something far deadlier, a pyroclastic density current. This is not lava. It is a turbulent, ground-hugging avalanche of superheated gas, ash, and pulverized rock, moving at the speed of a hurricane. These surges were the true killers. They were denser than the surrounding air, so they hugged the surface, flowing like a liquid. They were so superheated, they incinerated everything in their path instantly. Nothing could survive their passage, and because of their incredible density, they could do the unthinkable. They could travel across the open ocean. The pyroclastic surges raced across the surface of the Aegean Sea for dozens of kilometers, an unstoppable wave of death that annihilated the coastlines of nearby islands like Crete, wiping settlements from existence in a searing, silent blast. But the pyroclastic surges, as devastating as they were only a symptom. The true cataclysm was the structural failure of the volcano itself. With its magma chamber now empty, the immense weight of the mountain above had no support. The stage was set for the final act. It began with a catastrophic implosion. The entire central cone of the volcano, an island miles wide, collapsed downward. It did not crumble. It plunged, acting like a gargantuan piston dropping into the void of the magma chamber a kilometer below the surface. This sudden, violent displacement of rock shoved the Aegean Sea with unimaginable force. It created a mega tsunami. Waves, estimated to be over 100 feet high, radiated outward, a liquid shock wave that would scour the coastlines of the entire eastern Mediterranean, reaching Crete in under an hour. This was the volcano's ultimate weapon. The destruction did not stop at the water's edge. The eruption had launched a massive plume of sulfur dioxide high into the stratosphere, far above weather systems. There, the gas reacted with atmospheric water, creating a vast, reflective veil of sulfuric acid aerosols that began to circle the globe. This planetary shield blocked incoming sunlight. It dimmed the skies and caused temperatures to plummet. Evidence preserved in Greenland's ice cores and growth rings from ancient trees in North America show a distinct period of cooling. The eruption on Thera had triggered a volcanic winter, altering the climate for years. Today, the most iconic and beautiful vista in the Aegean is a direct result of this ancient violence. The crescent-shaped Bay of Santorini, with its sheer, multicolored cliffs, is not a natural harbor. It is the geological scar left by the collapse. When tourists gaze out from the island's edge, they are standing on the rim of that ancient volcano. They are looking directly into its drowned, fractured heart. The cliffs are a cross-section of the very engine of destruction, a beautiful monument to one of the most powerful geological events in human history. And the scientific story is not over. While we understand the core mechanisms, crucial questions still drive research. Scientists meticulously analyze ash deposits across the region, piecing together the exact sequence of the eruption's final catastrophic hours. How quickly did the caldera collapse? Was it a single, terrifying plunge or a series of staggered failures? Answering these lingering questions is vital. It helps us refine our models for predicting the hazards of similar, active volcanic systems around the world, turning a deep understanding of the past into a tool for protecting the future. The eruption's fury, in a moment of geological irony, became the ultimate preservation tool. On the island's southern shore, the Minoan city of Akrotiri was entombed, not by lava, but by a delicate yet complete blanket of fine volcanic ash. This act of fiery burial created a time capsule. The ash acted as a desiccant, wicking away moisture that fuels decay. It perfectly molded itself around buildings, pottery, and furniture, supporting structures that would have otherwise collapsed over millennia. Archaeologists excavating the site found streets, multi-story buildings, and stunning frescoes frozen at the exact moment before the cataclysm. This sudden disappearance of a vibrant, advanced civilization resonates through history. It has led many to a tantalizing question. Could the eruption of Thera be the historical event that inspired Plato's story of Atlantis? A story of a mighty island nation that vanished into the sea in a single day and night. The parallels are striking. A circular island, a sophisticated culture, and a cataclysmic end delivered by the ocean. The timeline, however, presents a challenge. Plato wrote of Atlantis nearly 1,000 years after the Thera eruption. Initial observations suggested one outcome. The Earth revealed another. Scientific consensus does not equate Thera with Atlantis. The geological and archaeological evidence, however, confirms that the eruption caused the collapse of the Minoan civilization's dominance across the Aegean. The event's memory, a trauma seared into the collective consciousness of the ancient world, likely fueled countless myths, including perhaps the most famous lost city of all. Today, the Santorini caldera is one of the most beautiful places on Earth. But the geological engine that powered its destruction has not been switched off. It is merely dormant. Deep beneath the tranquil blue waters, the magma chamber is slowly but measurably refilling. The volcano is still very much alive. Modern science gives us an unprecedented view into this sleeping giant. A network of seismometers, GPS stations, and gas sensors monitors the volcano's every breath. In 2011 and 2012, the caldera floor swelled by up to 14 centimeters. This was a clear sign of new magma intruding into the chamber deep below. The volcano will erupt again. That is a geological certainty. The challenge for science is not if, but when, and on what scale. Predicting the exact behavior of such a complex system remains at the frontier of volcanology, a constant effort to translate the planet's deep murmurs into a clear warning. The story of Santorini is more than a tale of destruction. It is a profound lesson in Earth's cyclical nature. The same forces that obliterated an island and a civilization also created one of the most fertile soils in the Mediterranean. The same caldera that spawned a mega tsunami now forms a breathtaking, protected harbor. Destruction gives way to creation. This is the planet's most fundamental rhythm. The scar left by the volcano is not an ending, but a testament to the raw, untamable power that shapes our world, a constant reminder that the ground beneath our feet is part of a grand, powerful, and ongoing geological story.